Hello everyone, welcome once again to another Power BI related tutorial by Slidescope. In this tutorial, we are trying to create a patient blood test analysis dashboard. The dataset that we are using is the patient blood test data where we have taken data of 50 patients. We have age, gender, hemoglobin, WBC, platelets, glucose and cholesterol data of these 50 patients. And on the basis of that data, we will try to create a dashboard and explain you all the steps that are included in between. So let's get it started. So we have this patient blood test data where we have patient name, age, gender, hemoglobin, WBC value, platelet count, glucose level, cholesterol level, and we have data of around 50 patient here, which we have taken as a sample. And we will use Power BI to create a dashboard from this data. So let's get it started with Power BI. And the first thing obviously you need to do is just load that data. So here we will just load the sheet. Make sure that all the columns and values are appearing properly. Then you can load. And the one thing that you have to make sure is if in your data, for example, obviously we have patient name, age, gender, which is a categorical column. Then we have hemoglobin, we have WBC, platelet, everything is there. Most of the values are numerical, but we don't have any patient ID column. Okay. So what we can do with the help of transform data tab here, which will open Power Query Editor for us, we will add a simple column, which will be our index column. We will start from 1 and we will rename this column to patient ID. So every patient will have some unique ID, and the main purpose of adding this patient ID is we'll be able to count patient. Obviously, in our data set, which is a simple sample data set, we have 50 patients, but in actual case, uh, we are developing it for a we are developing this type of report for a blood test for a diagnostic center. So they have thousands of records. Okay, obviously for a lot of reasons we cannot share the real data, but the real data more or less looks like this only. So now we have this connected. The name of our table is sheet, so we can rename it to something like blood test. Okay, so that we will use this table name while creating various DAX measures or DAX columns. Here we have some dashboard visual ideas to present your patient blood test data in Power BI. Okay, so the patient overview section can be there where we will have card visuals for quick stats like total patients, average age, and gender distribution. So let's create these card visuals. And to create the card visual, first you have to select card here. And as we do most of the times, we just go to format visual tab and format it. But let's put some data here. So first we will select total number of patients. So as we created the patient ID, we will just drag this field and this is 50 count of patients. We will rename for this visual as number of, or we will simply call patients count. Okay, hit enter. And now when we will go to this visual, there we have the general tab, there we have the effect. In effect, we will enable a visual border and shadow, and then we will go to category label and increase the size of category label and its color also. So this time we can choose any simple color palette. Let's say we are selecting this color palette. Okay, so we will use this, and similarly for category value also we will use something similar. And this is what you can do. Obviously you can spend as much time here to make it more attractive. And in your effect, when you enable a visual border, you can also select the border color. So we will select something like this. So this is patient count, and we will simply resize this so that we can put more of these cards in the visual. We will simply Control C and Control V, or Command C plus Command V to copy the visual. You can right click and copy as well. So we will put it like this. Okay. So this is patient count, and in the second visual we will remove it and we will drag age, and instead of sum of age, because sum of age doesn't make sense, so this is average age. It is written average of age, which is correct, but if we write average age, that is also sufficient. Similarly, so we have patient count and average age, and we can write something like average platelet count, just giving an example, or average hemoglobin value. Okay, in all these 50 people, not sum of this, average. So you can see average hemoglobin value is 13.16. So the hemoglobin range between 12 to 14 is considered healthy. It also depends upon male and female. So we will also check average hemoglobin value for male and female. But here, this is overall average hemoglobin. So average hemoglobin, which is in gram per deciliter. Okay. So here we are just going to rename this visual. We'll remove this and we will use AVG so that we can fit the values here. Okay, average hemoglobin. This is just one example where you can put your card visuals on top to show different type of counts in your data. Similarly, we have glucose also. So we will fill the first row with glucose also, and here we will write average glucose value. This way you will see, like in your data set, what is the average glucose level, which is 102. uh, you know, if it goes beyond 150 or something, that is alarming and more than alarming. So you can see for entire data set the averages are good. Okay, so not it's not like everyone is suffering. So rename for this visual and we will call average glucose. Okay, and obviously from different internet research you can also create charts about what are the suggested glucose levels or healthy glucose levels, healthy hemoglobin levels. Obviously age and patient count won't matter, but you can do that. So this is a simple example that we did here. This upper portion we will use for putting filters. We will create a simple text box here and call it patients or patient blood test analysis report or dashboard, and we will align it to center, increase its size to around 28. Okay, and we want to put it here. Just a minute, sometimes it is hard to drag it. Yeah, we will just put it here, and here we can use some color like this. We are using this color for text, so first select it and then select the text, and we can go to properties, effect properly, and in effect we will just create a visual border, a shadow, and choose its color as the light yellow as we selected for other visual. So this is patient blood test analysis dashboard, and we have this data. Okay, we can go to insert tab, and in insert tab we can go to a shape. So we can put the shape here like this in the full width, and now in this shape what you can do, for every shape you can go to format section and send to back. Okay, this way what will happen, this particular visual will go to the background. Obviously we have to change its color. So in the shape we can show something like oval, rectangular, pentagon, whatever you want, and we just have to go to style, and we will use a light color like this, or let's try a dark color. Maybe this will do. Obviously we are using this palette, may not be the best color, but yeah, you can use something like this. Okay, so we can select a darker color, and this way you can put a shape in the background. You can also put an image in the background. So this is patient blood test analysis dashboard they have created, and we are trying to create, and this is our simple uh, case here. Okay, and let's increase its size, align it. We can increase the margin and padding, but this is what we want to achieve first. So we have achieved the first part, like card visuals. Then you can use bar and column chart, that is number of patients by age group. Okay, so what we can do here is, so when you will see in our data, so obviously the another thing that we have to do here is number of patient by age group, and this can be easily done with a histogram chart. So either you can import a new visual, so you can get more visuals, and then import a histogram chart here. Or what we can do, so in our data, when you will go to age and sort smallest to largest, you can see the smallest value is 25, the largest value is 60. Okay, what we are going to do, we are going to divide them in age groups like this. So if age is greater than equal to 20 and age is less than equal to 30, then we are going to call it 2030. Okay, 51, 60, yeah. If age is greater than 31 and age is less than 40, we will call them 31, 40. So we are going to label the values as this. So for every row, okay, so you can do it in Excel also, but we will try to do it with the help of DAX by creating a calculated column. So for example, this age is between 20 to 30. So we will just write 2030 here. Okay, because that's how we want to create the age group. You can decide your own uh, age group value, but this is what you can do. Or we can call it above 50 also, right? Because we have values from 20 to 60. So because when you will go, you will see the maximum age value is 60. So here, based on this condition, we have created a simple DAX query or DAX expression, which will be called age group. This is a calculated column because it will run for every row. And here we have switch. In switch, you write true for the first argument. So in the official documentation, you can see in switch we write expression value result. Okay, any DAX expression that returns a single scalar value where the expression is to be evaluated multiple times for each row. Okay, so this is the simple syntax of writing switch for this case. Here in our case, the name of table is blood test. Okay, so the only thing, So the only thing that we need to do here is just replace this with blood test. Okay. So if in blood test the age column is greater than equal to 20 and 2 ampersand signs are used, so that it means both these conditions will be applied and this will be the output. Okay. And below 20, default case for ages below 20, whatever we want to write, which is not true in our case. So we will write these four conditions and copy this. We will go to apply changes, let's say. Yeah, we will go to modeling tab. From here we will go to new column, because calculated column, and if everything is right we will see the correct data. Okay, so we have used this switch statement, and when you will apply this, your age group calculated column will be created. Let's verify that. So here age is 25, 20 to 30. Okay, so everyone between 20 to 30 is marked as 20 to 30. Everyone above 50 is marked as above 50, and this is the easiest way to do that. So we will provide this code to you as well. So in the document I have put this, so we will try and put everything that is working, so that you can also go and learn from that. Now since we have this column, what we can do here is, let's click outside. Okay, I am going to delete this for now, because it is again creating trouble for us, and add this later. Okay, so what we are going to do this time, we will use a clustered column chart, or you can also use a stack column chart, whatever you want. We just want one visual there, so we will put it like this. Okay, in the x-axis we will put the age group. Okay, because we have the age group here. Okay, and what we want to know is count of patients in every age group. Okay, number of patients by age group. So for finding out count of patient, we already have the patient ID, and we will write it in this group, and this way you will have the count. Okay, so that means between the age of 31 to 40 there are 18 patients, 41 to 50 there are 13 patients, above 50 10, and only 9 patients are there in 20 to 30. So this way this will tell you count of patient by age group. And what you can do is, we can rename this as count, or patient count. Okay, now you can simply go to formatting part. In formatting part you can go to effects. In effects you can enable visual border shadow. We have visual, so on our y-axis we have values, you know, we have some color, so we will use our theme color that we are using. Okay, and we have the columns here. We have column color, so we will choose some color as per our palette. Okay, so this way we have this color, and in the title we will just align it to center, increase its size a little bit, make it bold, and choose the dark color. Okay, so this way we have patient count by age group. So obviously we have learned how to create simple visuals, and we have also learned how to create this type of calculated columns. Many times while you will try to learn all of this, you will go through this particular thing where you have to create age group wise data, and you can remember this simple thing, that this is how you can do it. Use the switch statement, write true as your first argument, and then put your conditions. Now next up we have hemoglobin labels. Obviously we created some values there, and before that we also can create a gender distribution, that is male to female ratio. Okay, so what we are going to do here, we we can use a donut chart or a pie chart for that. Let's create a pie chart, and we will just adjust its height and width equal to our bar chart, and here go to, before going to visual we actually have to get data. So in legend you always put a categorical value, which is gender in our case. So we have the male and female genders here, and here also patient ID. Remember, this is very useful that we created it. In this data set, obviously there is equal distribution of values. Okay, so that is great. And in details you can put something like, I'm just giving an example, for example hemoglobin. So this will create a chart like this, like hemoglobin wise distribution. Okay, and you can also write age here, so you will see age wide distribution. So you can use a pie chart for that purpose also. Let's go to visual. General title is something that we will use the color that we are using, size similar to previous visuals, and everything is correct. In visual you have slices, so let's use some color palette like this, or we can go to more colors. Let's use this color for female and this dark color for male. This way we have these values, and you can increase the size of these markers also. Okay, so like detail values are there, and its color is font, so you can do it like that. And everything that we do every time, visual border and shadow. Now we will go to our visual, and instead of count of patient ID we will just write count of patients by gender. Okay, so this will create a simple count of patient by gender visual chart for us. While creating the chart I have got an idea, why not put this heading on top. Okay, so because the sidebar space we can use for filters and other things. So this is patient blood test analysis report, and this way we have patient count, count of patient by gender, patient count by age group, so which is giving us good indication of how the data is behaving or what type of data do we have. Okay, we can shift them up so that we reduce the space, so that we can bring other visuals also. And by the way, these are all interactive. So for example, you want to see in 41 to 50 range how many uh, male and female values are there, so you can do it like that. Okay, so next up is suggested that in God chart or whatever chart you have to display the average hemoglobin level with ranges. Okay, so what happens is in the data that we have, let's see on Excel itself, not this one. Yeah, so we have the hemoglobin value. So some of these values will be in low range. Okay, some of these value will be in high range, and some of these values will be in suggested or average range. So in the same way as we created age group range, we will create the hemoglobin range column. Okay, so just copy this, and modeling tab, new column, and we will create this. Okay, obviously In some other cases, 11 may be considered as low. Obviously, as I said, hemoglobin value differs on gender also. Like there is a different range for male and female. So, but here we are just giving a simple explanation of how to do that. And we can select, we can apply multiple conditions also, like hemoglobin is greater than 12 and gender is male, then normal. We can add multiple condition layers also here. So after doing this, you will again see this column and you can check also, like for example 11.7 low, normal. So most of them are in normal range. Okay, so and now we have a gauge chart here or gauge visual, and in the gauge visual we have, we can select a value, a minimum value, a maximum value, a target value and tooltip. We will simply create another measure here which we will call as average hemoglobin. Okay, so average hemoglobin will be AVG hemoglobin or whatever you want to call it. So this will not be a column because it's an aggregate value. So in modeling we will go to new measure and here we will calculate the average hemoglobin. All of this will be needed. I'll show you where. And we already have average hemoglobin here, but if you will select this just to check, let's create another page here, create a simple chart here and drag. Okay, this is average hemoglobin. We can rename this to report analysis, whatever you want to call it. Now once we have created the calculated column and the average value, so we will drag the average hemoglobin to value in the gauge. Okay, so in the gauge visual, drag average hemoglobin to value. So this will give you average value. Then here in the gauge itself, set target value. So we can write some target value. Let's say we have to write 14 here. So we have created a simple measure here, call it target HB, and we will drag it to target value. So this is the target value. This is now the average value. In gauge you can see both of them. In minimum you can set a low expected value. So let's call it minimum HB. Obviously there are multiple ways of doing this. Let's say the minimum HB is 5. We are giving it, it can be 0, 5, like whatever is the lowest value. And similarly new measure, we will call it max HB. Hemoglobin we are calling as HB, and let's say 19 or 18 or 20 you can write. So this is the max HB. Okay, so max HB value, the threshold of high hemoglobin count differs slightly from one medical. It's generally defined as more than 16.6 uh, grams per deciliter for men and 15 for women. Okay, obviously there can be different conditions, so let's say 16.5. Now in minimum value just drag the minimum value, and in your maximum value just drag the maximum value. Okay, so this way our gauge is being created. The values that we have created here, we can also calculate it with the help of minimum of the column value. Okay, for example we have hemoglobin, so whatever is the minimum value we can calculate it like that also. if you want to go with your data range. But here in after format visual is after building our visual, we will go to format visual. We have gauge axis. Here you will see a minimum, maximum, auto, colors. So for example, if we did not have this maximum value, minimum value, and if we go to gauge axis, then we can set minimum and maximum value. So you can add field value. So what field value should we base on this? So here also we can set minimum and maximum values, like let's say minimum is 5, maximum is 16.5. Okay, here also you can set, and target we have already set to 14, and there are colors, like you can select different type of colors, so for minimum, for maximum, and your target value color. Okay, you can set it like that. So this way you can just create your gauge chart, and let's choose a different color. Yeah, maybe darker. Yeah. So this way you can select your gauge color here, and here in the title, which is saying average hemoglobin and target hemoglobin. Okay, you can define any color, font, align to center. What we can do, one more thing is, we can create a table visual, and in the table visual, we can select a matrix also, and in the matrix what we can do, we can select patient name, which is count of patient. We can select hemoglobin level, like low, normal. Okay, the count of values that we are getting, how many low, how many normal, and we can drag all patient name here to see this data also. Not so, what we can do, we can drag a table visual here also, and in the table visual we can drag the patient name. So we have the patient name here, the hemoglobin value, the average. From here we can also set the target value, but we want to show the hemoglobin range, whether they are, normal, low, whatever they are. And we can go to table, in a style presets we can select flashy rows. Okay, and here we have different options, like in the grid, the color that we want to use. So what I have done here is, I have selected the bold header preset, and I have selected in column headers, I have selected background color as our theme color and text as bold. So this way you can add the patient data here also. It's your choice what you want to do with it, but we always enable some effect. Okay, so like we enable visual border and shadow, we enable visual border and shadow, and shadow color is also something that we can define. So this way we have a very simple patient blood test analysis dashboard. So we can copy this entire thing, paste it in a new visual, and this time we are going to remove this. Okay, we will select the scatter plot, and why we are selecting the scatter plot is because with the help of a scatter plot We will show relationship between WBC and platelets to identify correlations or outliers. So this will be our WBC and platelet analysis. Okay, is there some kind of relationship? So we have WBC and we also have platelets. So here in x-axis we will drag WBC in the scatter plot, and in y-axis we will drag platelets. Now it will always show you single drop or single dot because it is sum of WBC. So we will say we don't want to summarize the data. Similarly here, don't want to summarize the data. So here you can see it is showing us a linear trend. Okay, so this is WBC and platelets. So we will simply uh, rename for this visual as WBC, and for this we will rename for this visual as platelets. So this is WBC and platelets relation, and we will go to title, and WBC and platelets you can call relation or versus platelet, whatever you want to call, and we will simply choose the size as per our previous settings. Okay, and here in the visual we have x-axis, y-axis, markers. So in marker we have shape. Okay, so currently dots are there. If you want, you can select different shapes like diamond shape or square shape, and in the color we will definitely choose something that we have done so far. Okay, in your x-axis title, increase the title so that it's visible. Okay, and color, so we will show that, and similarly in the y-axis also in the title we will increase the title and color. So this way we have this data, and again go to FX, and in FX we will enable shadow and visual border. So this is relationship between WBC and platelets. So when WBC is increasing, platelets are also increasing. What we can do next is when you have selected this, you can go to add further analysis to your visual, and here you can turn on the trend line. Okay, this trend line uh, shows you the trend of this data. So a trend line in a scatter plot shows the overall direction or pattern of the data points. It represents the relationship between the x-axis, that is WBC, and y-axis, platelets, helping to identify whether positive trend, that means as WBC increases, y also increases, or as x increases, y decreases, or no clear pattern or relationship. So in our case, there is a positive trend. The trend line can also highlight outliers and provide insights into the strength of the correlation between two variables. Now, the next thing that we can do easily is we can go to our visuals. From here, we can drag slices. Sorry, not here. So we can drag slices, and with the help of slices, we are going to create some filters. So the first filter field that we are going to select, which is categorical, is gender. And here you will see gender male and female. So if you want, you can select both of them. In slicer settings, obviously vertical list is fine here, and we can increase color and size of these values, make them bold, increase size, and same we can do with the title also. So just a minute. Yeah, so we will enable our title and call it gender. We don't want two titles, to be honest. So in slicer header it is already given. So we will just increase its size, make it bold, change its color to what we are using. Okay, and we will just increase its size so that the slider is not there, and we will enable border and shadow. So this creates our gender slicer. So if you want to select for male, you will see the pattern. If you want to select for female, you can see the average and target value are, there is a big difference between average and target value. In case of male, it is actually meeting the target value. So this way you can see the difference. Count and everything will also change. Okay, and similar way we can, we have created two more things, like we have created hemoglobin range also. Okay, so we will just drag this, and instead of gender we will bring hemoglobin range here. Like we want to see how many of them are low, like people who are falling in the low range, they have average hemoglobin of 11.82. 5 patients have low hemoglobin, and all of them are female in this case. Their average value is this. Their glucose value is 92. Okay, so you can, as we have created WBC versus platelets, you can create more graphs where you can put things like hemoglobin versus glucose, WBC versus glucose, and there can be n number of possibilities here. As we have done hemoglobin range, we will also select age group. Okay, and in all of them what we can do, uh, we can enable select all also. So you can go there, and in your slicer setting selection you can show select all if you want. Okay, so that is what you can do, and here instead of hemoglobin range we are going to show the age group which we created. So these are the age groups that we have. So now we have these filters, and let's click somewhere here, let's apply filter. And what I'm going to do, because we have enough space, I will enable select all, because sometimes that creates a problem. So I'm going to just drag them below like this and like this. Okay, so select all, select all, select all. This way we have the entire data. So we have these values, and now this is a simple dashboard that you can also try and create. And if you want, you can insert, put the, you know, diagnostics name here. We are just writing our training center's name here, and here from shape, as we did it in initial steps. After building all of this, we can just bring the shape, go to format, send to back, and in the shape itself we can go to shape, style, color, and choose something as per the data. So this is our simple dashboard, and let's get rid of the shape. Yeah, so this is our simple dashboard, and we can actually try to increase it by one font. Yeah, so let's click outside. So this is our simple dashboard, that we created to analyze the patient blood test data that we had. You can also try this. I will leave the dataset link in the description and the article link in the description from where you can copy the DAX queries. So we will try to create another part where we will do more of um, analysis, but here you can try more things. So I have put here like you can create one for glucose level, one for cholesterol insight, one for comprehensive health score. So you can try that. Okay. If you like this video, please subscribe to our channel so that you can learn more data analysis related stuff.